Today I'm going to do something that I have never done before, at least on the channel. I'm going to build an airplane. Now, I've built airplanes before, a long, long time ago when I got into the RC hobby with airplanes. But I've never built one on my channel, and I've never built one like this, a VTOL version. This plane can switch from flying like a multi-rotor to flying like an airplane, which means it can take off and, more importantly, land vertically. And it's not running RG Pilot, it's running iNav, which means it's going to be accessible to a whole lot more people who maybe don't want to deal with the complexity of RG Pilot. Do you want to come along with me and build this airplane? And I'm recording this at the end of the video, so you know for a fact that by the end of this video, I built a flying airplane I didn't just like get 45 minutes into the video, hit a stumbling block, and decide to publish the video anyway. I would never do that. Nope. Flying airplane. You come along with me. I'm Joshua Bardwell. You're going to learn something today. This was a real experience. Before we get into the video, I want to acknowledge that some of you are going to be building this plane along with me, sort of as beginners, and I'm going to take you through a whole bunch of basic stuff that people who are experienced with building planes already know. And some of you are just here because you want to figure out how to do a VTOL plane with iNav, and there's a few tutorials out there and a few instructions, but nobody who has taken it to the level of, shall we say, depth and clarity or long-windedness that I do. If you're here just for the VTOL stuff and you already know how to build a dang airplane, I've got chapter markers and I'm going to put the word VTOL at the beginning of the chapter markers that specifically relate to setting up iNav with a VTOL plane, and you can just skip right to those, hopefully, and get what you need. And it should go without saying that all of the stuff I'm using in this video, there are links to all of it down in the video description below. Some of it's affiliate links, some of it isn't. But if you're like, where did he get that thing? It's all linked in the video description below, because I hate it when somebody shows something on screen. Ooh, what's this? I hate it when somebody shows something on screen and they don't tell you what it is. Why? Oh, the battery's dead. The battery's dead. The battery's dead. The battery died. I wasn't monitoring the battery. It definitely exploded a little bit. Hopefully not too bad. The T1 Ranger comes from HEEWING, set up for the servos to plug directly into a receiver and for you to have full manual control of all the controls. But that's not how I'm going to be building it. I want to build this with a flight controller so I can take advantage of all the autonomous flight control stuff that you can do with modern flight control firmware. And the flight controller we're going to be using for this build is the Matek H743 Wing V3. And certainly there are those who would say this is overkill for such a small plane, but who cares if it's a small plane? I still want to make it jump through hoops and do a cool thing, and I want to have like a top-of-the-line flight controller. So this is the flight controller we're going to use, and I want to take some time to plan out the wiring for this build. And there's two reasons I want to do that. Number one, I'm not as experienced building fixed wings with iNav flight controllers. If this was a multi-rotor, I would already know where all the wires were going to go. I don't. And the other thing is that iNav, it's not as easy to just remap a control. If you put like a servo on the wrong motor output, you might have no choice but to move the wires. Whereas in Betaflight, you can usually do remapping in software. And I'm not going to be using the pins that come with this flight controller, these things. I'm not going to be using them. And I'd love to tell you the reason I'm not using them is because like I'm a purist and I direct solder everything. But the truth is that I don't have any like servo plugs that you can just crimp on. And so I'm going to direct solder just because I don't want to wait to start this build until I order some servo plugs. So what we're going to do is we're going to take this flight controller, we're going to plug it into the computer, and we're going to go into iNav. Oh God. There is a switch. There's a little switch on the USB that turns the beeper off. Don't forget that you've done this, or later you'll be working with your plane and you'll be like, why is my plane not beeping? Why is my plane dead? And it's because you turned the beeper off. Here in iNav Configurator, we're going to go to the Firmware Flasher tab, and we're going to type in the targets Matek H743. We're going to look here. This is the target we're going to flash to this board, and our firmware version is going to be, well, I'll choose 712. That's the latest at the time that I'm recording this, and it's the one I'm going to do the rest of the build on. You definitely want to update the firmware because this comes from the manufacturer with firmware like 4. Whatever. It's ancient. So you definitely want to update. And the other thing we almost always have to do, at least in my experience when working with this flight controller, is if I just plug in USB, it is not going to go into DFU mode and I'm not going to be able to flash it. So what I'm going to do is I'm going to hold down the bootloader button here on the little USB board, and then while holding it down, I'm going to plug in USB. And when I do that, I should see DFU here in the upper right, and that means I'm ready to flash. Load firmware and flash firmware. Having done that, I will connect to the flight controller and I will choose an airplane with a tail as the preset that we're going to load, and that'll do some of the work for us. And by the way, there used to be a bug in iNav Configurator where it would hang on this screen, and if you're experiencing that bug, you need to download the latest version of iNav Configurator. I think it's 7.1.2. They fixed that bug. Next, I'm going to go to the mixer screen and I'm going to take a look at this graphic. And this is going to tell me which outputs on the flight controller are going to be used by default for which control surface. And yes, I know we could go down to the servo mixer and we could modify which output is which, but our life's going to be a lot simpler if we just stick with the defaults. So I can see here that we've got outputs S3, 4, 5, and 6 as our elevator, left and right aileron, and rudder. And if I look right here on the flight controller, we can see there's S3, 4, 5, 6, and so on. But we're not done yet. There's one more thing we need to do. This airplane has 2 motors, but you can see that the mixer right here has only 1 motor. And we want to take advantage of those 2 motors for 2 reasons. Number one, if you have 2 motors on a single motor output, then the motors will always be at the same speed. And that's okay, but it doesn't let you do differential thrust. If you have 2 motors on 2 different outputs, you can run those motors at a different speed, and you can use that to get additional yaw authority, more yaw authority than you could with what the plane or what the tail gives you. But that's not the real reason I want it. The real reason I want it is that I'm going to be installing a VTOL kit on this that lets it actually tilt the motors up and act like a multi-rotor. It always comes back to multi-rotors in the end with me. And so in order to have the VTOL kit working, I have to have the motors on separate outputs. But I'm not done yet, because in order for the plane to operate in VTOL mode, I actually need a 3rd motor here on the tail, and here's how we're going to address that. In the Mixer tab, we're going to go down to the Motor Mixer, and you can see currently we have just 1 motor. I'm going to add a new mixer rule to add a 2nd motor and another mixer rule to add a 3rd motor. But there's a problem, because here in the output mapping, you can see that we have motors here, motors 1 and 2, servos 1, 2, and 3. You can see that we don't have a 3rd motor. And I think the reason for that is that these timers have not been reapportioned. I wonder if I hit save and reboot, will it fix that? Sort of. But I don't like what it's done. So notice here, we've got these blocks of timers. The blue is timer 3, the yellow is timer 5, the orange is timer 12, and so on. And whether each of those blocks is used for motors or servos can be changed, but all of the output pins within a single block have to be used for the same type of output, either motors or servos. And it's a problem because I think we're going to run out of servos. Like, I only have 3 motors, but I might have a lot of servos. And we've just wasted this whole block here on motor 3. Instead, what I'm going to do is this. We're going to make timer 3 be motors, timer 4 be servos, timer 5 be servos, and timer 12 be motors. And now you can see that motor 3 is over here on S11. But by putting the motors on timers 3 and timer 12, we've left these 2 timers with a lot more outputs, S3 through S10, for servos, and we'll have a lot of room to do stuff with servos, whatever it is we want to do. So that's going to be the end of the configuration of the flight controller for now. We're not doing the complete configuration. We just want to know which motors are going to go on which outputs, and now we do, and we can move back to the bench and proceed. The next thing we need to do is install the VTOL kit in the wings. I was tempted to start wiring up the flight controller, but it doesn't make sense to do the wiring until we have all the wires we're going to need to wire up. And in order to install the VTOL kit in the wings, the first thing to do is to remove the existing nacelle and motor. When you do that, make sure to make a note. So you see that this is marked L, so this is the left one, and we're going to need to make sure we put the left VTOL kit in as well. There we go. Now it'll come apart. The top half will lift off, the bottom half will lift off, and we are going to need to desolder this motor from this ESC. While the soldering iron is coming up to temperature, I'm going to pull these two screws and remove this connector from the wing as well. And the reason I need to do that is here on the underside of the wing, there is a wire going to the LEDs on the end of the wing, and that wire has a plug here in the connector, and we're going to reuse that plug for the servo, for the VTOL kit. In other words, we're going to lose the LED functionality, and we're going to have the VTOL functionality instead. So here in the connector, you can see this one is labeled LED. We're going to unplug that, and we're going to fish that back through the hole in the wing, and we're going to pick that out here. There we go. We're going to pick that out. There we go. And we're just going to remove that entirely from the wing. Does the LED come off the end? Do I just cut it? That seems glued on. I guess I just cut it. Feels wrong, but I don't think that comes off the wing. Here we go. And no going back now. Now we're going to desolder the existing motor. The VTOL kit comes with this pack of motors, and you'll see that there are two the same and one odd man out. These two are going to go on the wings, and this one is going to go in the tail. We'll set this tail aside for now, and we'll get out one of the wing motors. And we're going to solder that to the ESC. And you can see here, as is my wont, I'm using Kapton tape and not heat shrink to wrap this up, just because I find it more convenient to use. And just shove that back down in there. Actually, what let's do is let's just shove the ESC, yes, back down. There we go. And then the wiring will go how it goes. Next, we're going to get out these two packs of tilting servo mount is what it's called. At least that's what it's labeled. And remember that we were working on the left wing. We could go back and we could look at the previous nacelle that we removed. We're going to get out the left side of the tilting servo mount. And you can see this has a top and a bottom. Oh, that clearly doesn't work. Does it work if I go on top? Oh, that fits. That seems like it fits. What if I put it on bottom? Oh, that's definitely not right. That's not right at all. Okay, so this one is the top, apparently. And you can see when I slide it on there, it fits just perfectly and it lines up with the front of the wing. So that's definitely correct. We're going to leave the bottom for now, and we're going to get out the servo. So we've got these servos. The servo is going to install with screws going up through these screw holes, and they're going to go into these mounting holes on the servo. The motor is going to just get pulled back, and the servo is going to lay down in there. And we're just going to put two screws in now to hold the servo in place while we finish everything up. In this bag, there's a bunch of mounting hardware and a small bag of screws. And when you install the servo, make sure that the drive side of the servo is facing the wing tip, not the root of the wing. When we're done, we will have the top half of the motor mount installed in the wing. We'll have the servo mounted with two screws here and the motor sticking out the front. Next, we're going to get the motor mounting plate. And the motor mounting plate has a flat side and then a side with recessed screw holes. We're going to mount the motor to the flat side. I do want to point out a nuance of how the motor base is installed. You notice that the motor base has a wider side and a narrower side, right? It's not centered. The motor's not centered. And it seems to me like the way it's supposed to work is that the motor is centered in front of the mount and the wider side goes toward the drive. The next thing we could do is we could mount the motor to the servo using these two servo arms, but I'm actually going to hold off on that because I don't know for a fact that my servo is centered, and I don't like mounting the servo arms until I've got power to the servo and can verify its position. So we're going to hold off on that for now, and we'll just stop right here. Next, we're going to take the wire from the servo and we're going to run it through this channel in the wing back out, and we're going to plug it into the wing the plug where the LED wire was. And we can reinstall the wing plug back in the wing. And if we're feeling very confident, we can install the bottom half of the mount like so. Although again, if I have to end up opening this up to reverse the servo, I'm going to be, or the reverse the motor, I'm going to be very sad. But, you know, let's live dangerously. And for now, this is the state that we want the wing to be in. Make sure you've mounted your servo with the drive side facing the tip. Everything's put back together. All our screws are inserted. And we're going to do the other wing the exact same way. But I'm going to do that off camera. The next thing to do, I guess, is the tail. I want you to notice that there are two tail booms here. There's one that came with the VTOL kit and one that came with the original plane. We are not going to use the one that came with the original plane. The one that with the VTOL kit is a little longer and has this cut out here for the motor wires. We're going to take the rear motor that came with the VTOL kit. We're going to fish those motor wires into that hole, and they are going to go, I believe they're going to go the opposite direction of the triangle. They're going to go toward the base of the triangle, and they're going to feed them all the way through till they come out the other side. Be careful as you're pulling them through. Don't catch them on this lip. Like, feed them through gently. If you just pull from this side, they may catch on this lip and it may tear the insulation, and that would be bad. I'm just going to push those all the way through until the motor is fully seated like that. Looking at the installation instructions from HEEWING, it seems like they actually want it to go like this. I don't know why, but okay, it's pretty clear that that's how they've done it. And we're going to take this little piece and it's going to screw to the motor base and then go around the tail boom. Feeling like I must have misused some of these screws somehow, because I'm running out of the screws that I think are the right ones to use. I don't know, man. I wonder if I should have been using some of these pointy screws instead of the fine thread machine screws to mount the servo, because the servo wasn't threaded, whereas the motor bases are threaded. I wonder if the fine thread machine screws should be used for the motors, and these coarse thread screws should be used on the unthreaded servo mount. This will not spread open and clip around the boom. I'm going to have to pull the wires out and feed it on like this, and then fish the wires down in. We're going to get the 20 millimeter M2 screw, and that's going to go through here and tighten that down. Let's just make sure this is centered up with the top of the boom. Next, we're going to take the tail servo and feed it through. And there's supposed to be some kind of like a pull wire, because as you can see, it doesn't want to go through with the motor wires in the way. Crap. Should I have done that first? I don't know where this pull wire is. There's pictures of it in the instructions, but I don't seem to have it. Or if I do, I haven't found it. So I think what I'm going to need to do is, I think I'm going to need to fish this through first. Do we? No, we only have, we don't have a rudder. Interesting, there's a vertical stabilizer, but no rudder. Okay, fair enough. So that's going to go on. We'll just seat that in place. There's going to be a screw that holds it, but I'm not worried about that now. Then let's see if we can fish these down in. Get that motor squared up as best I can. Just double check here that we haven't got any pinched wires or anything. I don't think we do. Everything is pulled through, and the tail is fully inserted. So we'll go ahead and mount the tail. Clip it on there. M2 by 20 goes here. So in this bag of parts, there is going to be what they're calling a 2 by 20 screw. I believe that is this dude here. And that's going to go in the tail. Oh, it's gone. I see. So it's going to push all the way through and go into the vertical stabilizer. Got it. Well, it didn't go through very much. It's just screwing into the plastic. Is that correct? Is 2x20? Is there a longer one? No, that's it. That's the one. And there's a little lip here. So we're going to go push forward like that so it catches on the lip in the back. And then, yeah, like that on the front. There we go. Now it's fully biting. It wasn't fully inserted, so it wasn't biting on the threads. Don't over tighten that because you'll strip that. But there we go. Now we're looking good. And we're going to do one of these little 2x6 screws right here. And I guess that's going to secure the tail boom. Next, we're going to take this large red nut. We're going to put the wires through the nut and feed the nut onto the tail boom with the flat side of the nut facing the end of the boom. And we're going to feed these wires through into the main fuselage and slide the tail boom on. And it should seat, there we go, it should seat in, fully inserted, and if you wiggle it, it shouldn't have any wiggle. And then we'll tighten down this nut. Oh, that'll hold the tail. Instructions say you do not need to over tighten the nut as long as it's not loose. Next up, we're going to find this ESC that came with the VTOL kit, and we're going to solder the 3 wires from the tail motor to that ESC. So here we've got the tail motor ESC soldered up. It does come with wires and bullet connectors if you didn't want to direct solder it, but that's not how I roll. I have got the capacitor installed, and I've got the power leads soldered up, but not soldered to anything yet. We're going to save that for later. And I've got the signal wires soldered up. Yeah, I don't think it matters which direction the tail motor is going to spin because it's a tricopter. So either way, it's going to be fighting the yaw from the tail motor with the 2 front motors. So I'm not too worried about motor direction there. I'm going to go ahead and wrap this ESC up. And I do like to put a zip tie or some tape around the capacitor because I think it secures the capacitor to the power lead and helps. The capacitor is just held on by those little spindly legs, and they can vibrate and crack and maybe break loose. So I think securing the capacitor helps with that. Kapton tape is not pretty. It's not as pretty as heat shrink, but it's super easy to apply after the fact. And I don't have to worry about like having the right size. It just goes on. So that's why I use it. Now it's time to start connecting all the wires to the flight controller. And in order to do that, the first thing we're going to do is we're actually going to take the flight controller apart. We're going to remove these 4 screws, and we're going to separate the flight controller from the PDB on the underside. Hey there, folks. It's Joshua from the future. This is your last chance to decide to use pins and servo plugs instead of direct soldering your wires. And having soldered on all these wires, I got to tell you, it might be smarter to do that. This is a lot of very tight soldering, very close together, and the insulation on these wires is plastic. It's not silicone, so it melts back and just makes a big mess. I've done my best with it. The main thing you need to know if you decide to use pins instead of soldering is that the aileron and the motor plugs on the plane all go to the same. The left aileron and the right aileron go together and they Y into the same servo plug, and you will need to split those out. It's possible that the VTOL kit, it comes with spare wires. And it's possible that you can just take out the Y wire that comes with the airplane, set it aside, and use the spare wires that come with the plane and just plug it into the flight controller in the necessary spots. That's not what I have done, but I'm telling you it might be what you should do. Good luck. I'm just going to cut all these servo plugs off and direct solder the wires. So I think that this plug here doesn't actually do anything other than carry power from the PDB. This is a PDB here, and it's got a voltage regulator on it. I don't think it does anything other than provide power for the servos and the motors. So I think we can actually just pull this one out and save that plug, save that wire for another day. These are useful. What I'm going to do is I'm going to cut the Matek, the HEEWING battery lead. I'm going to cut it, leave yourself a little slack, and we're going to connect that to the Matek PDB as if it was an ESC. Yeah, okay. That's the smart way to do it. So what we're going to do is we're basically going to use this PDB as a distribution board for the ESCs rather than solder everything to the Matek. The Matek doesn't have as many positive connectors. It's only got 2 positive connectors, whereas we're going to have 3 motors. So I think the simplest thing to do is going to be to connect all of the ESCs to the HEEWING PDB and then connect the HEEWING PDB to the Matek PDB, and that'll also give us a nice place to mount the Matek PDB. It'll make sense. It'll make sense. Trust me. So here is my Matek PDB, and I want you to see I've got battery positive here. Just tin that pad. Then I've got the current sense resistor, the shunt resistor, and then I've got ESC positive here and the negative pads here. And the positives matter because we need the input to be on this pad and the outputs to be here so that the current shunt resistor works correctly and we can know how many amps we're pulling. For the grounds, it doesn't matter. And what we could do is we could just solder all 3 of the ESCs to these 2 pads, but that would be a little bit messy. And instead, what I'm going to do is you'll see. First, we're going to do the XT60 though. So here's my XT60 lead, and that's where we're going to get power from. And then here is the HEEWING PDB. We'll tin this extra plus and minus, which they've clearly intended for the VTOL kit. And then we'll shorten up these wires. Let's just check how it's going to go. This ESC is going to go like tucked back here somewhere. This PDB is going to go like here-ish. And then these wires are going to be, about yay long. We stuff that back as far as it'll go. How does that work? Yeah, kind of wish I'd flipped that capacitor around. But I'm not sure am I gonna undo all this and go back and fix it? I'm disappointed in myself. I wish I was lazier. Okay, so now we've got the tail motor soldered to the PDB. Now let's connect the PDB, the HEEWING PDB, to the Matek PDB. Yes. And as I said, the HEEWING PDB is going to connect to the ESC pads on the Matek PDB because basically it's just a bunch of ESCs. And you can see why I've elected to do this without having everything mounted, because otherwise moving this all around would just be a giant pain in the butt. It's already kind of a pain in the butt. Here's the Matek PDB with the XT60 connected to the plus input and the minus. And here's the HEEWING PDB connected to the ESC output pads on the Matek PDB. And here's the HEEWING PDB with all the ESCs wired up to it. And that, my friends, is a pretty good deal. Now it's time to connect all the servos and ESCs to the flight controller. And I've done it, and it's a big mess, and you won't be able to make any sense of it, so I've made a wiring diagram. I want to show you in this wire, but this is a printed version. I'm going to put a graphic version on screen so you can see it clearly. You can screenshot it. You can do whatever you need to do. I want to point out that I've only showed the signal wires here. Every one of these wires also has a red 5-volt and black ground wire going to the appropriate pads. So you can see here for each of these signal pads along this row, there is a 5-volt pad. It's labeled VX for reasons which aren't important right now. That's going to be where the red wire goes, and then a ground pad here on this row. That's where the black wire is going to go. But I've only showed one line for all 3 of those wires. So here is the graphic version of that. You could just pause the video and do whatever you need to do. And when you're done, this is what it's going to look like. So having soldered all these plugs onto the flight controller, you might think the next thing to do is to plug them all into the wing and start playing with the servos. But there's one more step that we're missing, and that is we need to connect to the PDB and the flight controller together. And here's what that looks like. It's not that complicated. We've just got 4 wires here, current, VBAT, ground, and VX, and they go to 4 corresponding pads here on the flight controller. I've got the flight controller plugged into the airplane per the wiring diagram, which I showed you previously. I have screwed down the airplane PDB into place just to kind of start to neaten things up. And I have placed the flight controller on top of the Matek PDB, but I haven't screwed it all back together because, I don't know, I might I'm just not ready for that yet. And I haven't taped the flight controller down, but I'm starting to sort of clean things up and put the wiring how it's going to go. Next up, I'm going to install the wings on the plane. And I'm not going to install the carbon fiber center spars just because I'm going to be taking the wings off. That wing is upside down. I'm going to be taking the wings off later, but what I will do, because I don't want these to come plugged and unplugged when we're under power, it can damage things. There we go. Is I'm going to reach in and turn the little locking. There's a little tab here that locks the wing into place. There we go. Click, clickety click. And now we are ready for the very first smoke check. Awesome. No smoke. Let's log into iNav and start configuring. And the first thing I'm going to do is go to my mixer. And I want to see, I think I have 2 more servos that I need to define. Yes. So I've got the 4 control servos. Well, 4 control servos. One's for the elevator, which this airplane doesn't have. But I've got the 4 control servos here, but I don't have the tilt servos defined. So I need to add 2 more servos. Add new mixer rule, servo 5, and add new mixer rule, servo 6. And I'm going to save and reboot. And here we go, S7 and S8, servo 5 and servo 6. That matches my wiring diagram. So I'm going to go to the Outputs tab, and we will enable motor and servo output and save. There we go. I heard the servos go to mid position. This is what we want. All of our servos are set to mid position. And now we can set up the control horns and the control surfaces. And I think to do that, I'm going to go back to the bench where I have a little bit more room to work. I think the first thing I want to do is mount the motors. So I'm going to grab one of these servo arms and one of these, one with a bearing and one without. And I wonder which screws we're going to use. I don't know. I guess I'll figure it out. But the one with the bearings, this is at 50%. So we're going to set what position the motor is going to be at 50%. And I guess at full downward extension, the motor is going to be pointing straight forward, and at full upward extension, it's going to be like, I don't know, it needs to be able to tilt a little bit backwards. It can't just go to straight up, because we need to be able to tilt it back for the VTOL functionality. I'm going to guess that 50% should be like a little bit past 45 degrees. I guess I don't know the travel of the servo. Okay, so let's just assume that's going to be all the way down. And let's assume that up is going to be there. And so let's make 50% be like there-ish. Seems about right. And then this one just slides on. It's not keyed or anything. It doesn't have teeth. And if you just look at the countersunk screw holes, it'll tell you which way to put it on. Oh, it really presses down on there. And when that's done, we'll have one motor mounted just like so. Next, we're going to get the bag containing these parts. You should recognize it pretty easily. And we're going to get one of these, which I believe is a servo horn. And we'll break these 2 pieces apart. And just because I'm like that, I'm going to cut this little bit of plastic off. We're going to install this piece in the underside of the wing. Just press it all the way through. And it needs to go like that, facing that way, with the 3 holes facing the servo. And then on the other side, do note that this piece has a top and a bottom. There's a flat bottom and sort of a domed top. It's going to pop down on and just press together, and it should pop down and snap on in such a way that if you pull on this, it doesn't come out. Then we're going to get these 2 pieces, and we are going to screw them together. There we go. I find this a lot easier to do if I grab the push rod with forceps. I can start to turn it on. And what I want to do is we're going to put this in the top hole in the servo arm and the top hole in the this piece. And I'm going to do it that way because that's how the manual shows it. You can adjust the throw of the servo by changing this hole here, but that's not, I'm just going to do it this way because that's how the manual shows it. And what we want is that when this is installed in the servo with the servo in the mid position, and when this is in the top hole, that the control surface is perfectly centered. It is not lifted up, it's not pushed down, it's perfectly centered. So we're just going to screw this in and out to adjust its length until it is as close to the perfect right length as possible, so that the control surface is naturally centered when the servo is centered. And we can adjust this later using trims, using various software functions, but we want to start from the best possible position of having the servo's center be the control surface's natural center position. And now I will reassemble the plane and plug in the battery, and all the servos will go to 50%, and I can double check my work. And it's occurring to me that if I had plugged in the battery while I was installing the linkages, all the servos would have stayed at 50%, and I could have adjusted them without having to redo my work. But I didn't think of that. I wanted to put it all together with the wings off the plane so I could do the camera better, like you could see it better. Okay, here we go. Okay, so pretty clearly this one is too long. You can see that that control surface is raised up. This one is pretty well centered, and the tail is damn close but a little bit down. I'm just gonna pop these off and adjust them, and we'll move that like probably just literally a half a turn. Oh yeah, this is the way to have done it, just with the battery in, and then you could just instantly tell that it's correct. And the motors are, I don't know what the full throw on the servo is, but the motors are in the same position, so at least they're clocked with each other. Good, good. All right, servo linkages installed, check. Ooh, we're getting close. We're getting close to being able to fly this. Holy crap. Isn't it great watching me struggle through the absolute nonsense that is getting this all going? This video took me over 2 weeks to do, and I loved every minute of it. And if you are loving every minute of this video, please consider joining my Patreon as a way of supporting me. For as little as $2 a month, you can subscribe to me and make it possible for me to keep making the kind of content that you watch and hopefully love. And if you're like, nah, I don't want to do that, I just want to get on with watching the video. Cool, that's cool, I've been there. But every so often, after you've been watching a creator for a long time, you go, okay, man, you got me. I'm going to give something back. And if today's that day for you, there's a link in the video description below to my Patreon. And if today's not the day, keep watching the content. Maybe that day will come. Hey there, folks. It's Joshua from the future, as you might be able to tell from the fact that I have a completely finished airplane. The footage from this section of the video was, I'm going to say it was corrupted, but actually the truth is I didn't upload it, and then I cleaned out the folder on my hard drive where I store the footage that I've already uploaded and don't need anymore, and I have to re-record this section. So I'm going to do my best to re-record it based on the recording. I have one of the recordings, but not the other. So everything should go in the same order that it did, but it won't be the first time that I've done this. And the first thing I'll tell you is that off camera, I bound my Express LRS receiver to my Express LRS radio. I'm not going to give you a tutorial on doing that. If you already know how to do it, good. And if you don't already know how to do it, I'll put a link in the video description to my video about how to bind Express LRS. So that's done. And the first thing I need to do is go to the ports tab, and I have got my receiver on UART 6, and that's the default, so no change needed there. Serial RX is enabled on UART 6. And I've got my GPS on UART 2, so we're going to go over here in sensors, and we're going to set GPS for UART 2. If I were installing a video transmitter at this point in the build, then I would also make some changes for the video transmitter, depending on whether it was analog or digital. But at this point, I'm just going to do a line of sight build, because like that's going to accomplish the goal of this, which is to build a VTOL airplane, and we can slap a video transmitter in there later. That's not really unique to this build. And now we will go to the receiver tab, and we'll just make sure that as I move the sticks on the radio, yes, the channels are responding as expected. The channel mapping is correct. Throttle, yaw, pitch, there we go, and roll. Okay, the configurator is a little glitchy, but I've seen that before. That's all set. Endpoints are correct. Channel mapping is correct. That all checks out. Next, we're going to go to the Configuration tab, and we're going to enable the GPS for navigation and telemetry option. And as long as we're here, we're also going to set the I2C speed from 400K to 800K. You'll see that the guideline there said change to 800K if the flight controller supports it. So how do you know if it supports it? Well, I'm going to save and reboot. And then what I want you to do is look down here at the bottom of the configurator where it says I2C error 50. Now, it's normal that there are some errors, around 50 errors is usually what I see when the flight controller first boots up. But what we don't want to see is we don't want to see that number continuing to increase. That number should be a relatively low number, around 50 or so, and it should not be going up. And that means that everything's okay with your I2C bus. The other thing I'm going to do here is you'll see that my GPS has a compass or magnetometer, and it's been auto-detected and is working. I have a blue mag and a blue GPS icon. I'm going to disable that. And you might be thinking, I'm going to set that to none. And you might be thinking, don't I need a magnetometer, a compass, in order to do autonomous flight? And the answer is usually yes, but not necessarily. In iNav 7, it might be 7.0 or it might be 7.1. I can't remember which version they added this. In this version of iNav, we don't need a compass. iNav can get an approximate heading from the GPS data. The GPS reports which direction we're moving, and as long as we're mostly facing in the direction we're moving, which for an airplane we usually are, and even for a multi-rotor we usually are, as long as we're mostly facing in the direction we're moving and we're moving forward, we can get a usable heading indicator without actually having a compass. And so why not use a compass? Isn't a compass better? Yes, a compass is way better, but a compass adds complexity around calibration, and especially on a small aircraft like this, the compass data can be really noisy and difficult to calibrate, and it can just be a big hassle. And so we're going to sidestep all that nonsense just by setting the magnetometer to none. And since I'm Joshua from the future, I can tell you it still works just fine. Next, I'm going to go to the Modes tab and set up my flight modes. And you don't have to set your flight modes up exactly like I do if you have a preferred way of doing it, but this is how I'm going to do it. First thing I need to do is set up an ARM mode. And being Express LRS, that's always going to be channel 5 high. That's required by Express LRS, at least as of today. As far as flight modes go, I'm going to have my flight modes on this switch, and the default is going to be angle mode. Hang on, there we go. And it's going to be with the switch in the up position, it's going to be angle mode. And we're going to have acro mode be the switch in the down position. And in this case, there's no acro mode. It's just when I'm not in angle mode, I'm in acro mode. So if I save that and then flip the switch down, there we go. We can see acro mode turns blue down here in the bottom. When I first did this, I encountered what I think must be a bug, although maybe it's not a bug, where the modes tab would not indicate acro mode. It would not go out of angle mode until, for some reason, I think it's related to calibrating the accelerometer. But if your modes tab is kind of being weird and refusing to go into acro mode, and that may be just because you haven't finished the setup yet, don't freak out until the very end. And then if it's still not working, then freak out. So we got angle mode, we got acro mode here. I like this switch here to be my nav switch. And the nav modes I like to have are loiter on the middle position of the switch and return to home on the downward position of the switch. And the reason for that is that I want to go to loiter first, and then if loitering, then I'll return to home, but I don't want to start returning to home and then loiter. So I can go into and out of loiter without triggering return to home is how I'm going to do that. Now that the aircraft is powered up, I should be able to move these sticks and move the servos. Let's test it out. Okay. Yes, and you can't see the tail, but I can also see that the tail is moving. What I want to do here is verify that the servos are moving in the correct direction. So yaw is just a placeholder. We're going to do something with those servos later, but we just put those on the yaw stick just to see that they worked for now. So forget about that. As far as the ailerons go, when I move the stick to the left, the roll stick to the left aileron should go up and the right aileron should go down. And that is not what's happening. That's the opposite of what's happening. Do you see I move the stick to the left and the left aileron goes down? So we need to reverse those servos. And that is servos number 2 and 3, which I can see because when I move that stick, those are the servos that move. So I'm going to go servo 2 and 3, and I'm going to reverse them here in the Outputs tab. And if I save that, That worked. Sometimes in the Outputs tab, when you hit Save, the servos just glitch out and you need to reboot the flight controller. So I might just get in the habit of hitting Save and Reboot. But that time, it didn't glitch out, and now my ailerons are moving the right direction. When I push the stick left, the left aileron goes up. Now, as far as the tail goes, here, I'll just turn the plane around. When I pitch back, the tail should go up. And it doesn't, it goes down. So the tail servo is also backwards. I can see as I move it, that is servo number 1. And I'm going to reverse servo number 1. Save and reboot. Now it's time to set up the VTOL functionality, the ability to take off and land in VTOL mode and then switch between forward flight and VTOL in flight. And I want to acknowledge that the first time I did this, I worked solely off of this document from the iNav wiki. I didn't figure this out on my own, but many people seem to struggle with following wiki pages and want me to walk them through it. And that's exactly what we're going to do in this video. However, if you're interested in finding this page as a reference, or just because you don't want to listen to me talk for 20 minutes, it's linked in the video description below, of course. And the first thing I want you to see here is that iNav supports different mixer profiles and different PID profiles. And the basis of setting up a VTOL wing is that you're going to have one mixer and PID profile for the wing and one mixer and PID profile for the forward flight, and then you're going to switch between them. So we're going to start by setting up mixer profile 1 as a fixed wing. And we've already kind of done that. When we first flashed this flight controller, we selected airplane with tail as the mixer for this profile. And actually, the first thing we need to do is go to the Mixer tab, and we need to enable the option PID profile will use the same index as mixer profile index. What that's going to do is that's going to mean that when we switch mixer, we also switch PIDs instead of being able to have mixer profile 2, but PID profile 1. If you think about it, an airplane and a multirotor have different PIDs. Does that make sense to you? If not, take my word for it. We need them to switch together. So we will enable PID profile. We'll use same index as mixer profile index and save and reboot. And then we will change the mixer profile to mixer profile 2. It'll disconnect and reconnect. We will again go to the mixer and we will enable that here. So that option is stored per mixer profile. So we'll need to enable it twice and we'll save and reboot. Once I've done that, you can see that I'm on mixer profile 2 and PID profile 2, but if I switch back to mixer profile 1, it'll automatically switch to PID profile 1. What I'd like to do now is go to mixer profile 2 and set up the VTOL mixer. So go ahead back to mixer profile 2, and we'll go to the Mixer tab. And normally what I would do is I would select a tricopter mix from this pull down. We have 3 motors, and this isn't exactly a tricopter because a tricopter has a servo on the tail, but it would at least get us set up with 3 motors, and then we could do the rest manually. However, oops, what the heck? There's no tricopter here. I don't know where it's gone. I don't know why it's not here. Maybe it's just not here in iNav 7.2. So instead, I guess, what we'll do is we'll select a quad X and we will load and apply the mixer. That's fine. And that'll at least get us set up with some motors and some mixer, and we can work from there. Now, the next thing I'm going to do is I'm just going to delete this 4th motor. I only need 3 motors, and we're going to have to change these mixer values. And in case you don't know what a mixer is, the mixer is telling the flight controller which axes of rotation this motor can control. So you can see that for all 3 of these motors, they've got a 1 on the throttle. What that means is that all 3 of these motors have full effect on the altitude of the aircraft. The motors go faster, the aircraft goes up, the motors go slower, the aircraft goes down. And that makes sense because all of these motors are on a plane with each other. So if we had one motor that was facing backwards, it would have a 0 in the throttle because it would make the quadcopter go forward, or the whatever multirotor go forward, not up. And then we've got roll and pitch, which is showing how they affect the roll and the pitch axis. A 1 would mean it rolls it to the right, and -1 means it rolls it to the left, or vice versa. I don't actually know which it is. Here's what those values need to look like for our multirotor. And honestly, I just copy this straight from the wiki page. Here's the information we need right here. We're just going to copy these values. And we just need to double check that motor number 1 is our left motor, and motor number 2 is our right motor, and motor number 3 is our tail motor, as shown here. For us, we could go back to our wiring diagram and verify motor number 1 is on output S1, and it is our left motor, and so forth. Then we're going to go down to the servo mixer, and we're going to add mixer rules for our servos. And we're going to, again, get that information from the wiki. And you could just copy what you see here, but I kind of want you to understand what you're doing, so that, because I think this is one of the most interesting parts of this build, is setting this mixer up, which makes the sort of VTOL plane work correctly. So we're going to start with servos 1 and 2, except are those servos 1 and 2 for us? Because this is labeled left tilt servo and right tilt servo. Again, we go back to our wiring diagram and we double check. And for us, servos 5 and 6. 5 is the left tilt servo, 6 is the right tilt servo. So that's what we're going to do. We're going to add new mixer rule, 2 new mixer rules, and they're going to be servos 5 and 6. And the input there is going to be stabilized yaw. Stabilized yaw. Because when this aircraft is in VTOL mode, it has no yaw control. It's going to get yaw by countering these servos. You can see when they go this way, it will push the yaw that way. And if they go this way, it'll yaw the other way. So that's going to be our yaw input. And the weight they have is minus 50. 50 there means that we're going to only have 50% authority, and the minus means we're going to sort of invert the direction that they move. When we go to test this, if they move the wrong way, if we yaw left, but they move so as to yaw right, we would invert that. We would have it be positive 50 instead of minus 50. Similar to how we reversed the servos in the output screen earlier in this build. But we're going to leave that at minus 50, and frankly, I might actually put it at minus 100. Just to give full yaw authority. I don't know why it's at minus 50. Maybe I'll do minus 100. Or maybe I like to live dangerously. Maybe you should do minus 50. Now, let's go ahead and plug this in so we can see the effects of our actions. And you can see here that we do have stabilized yaw being output to these servos. I don't know do you see that if I wiggle it on the yaw axis, they move so as to counteract the wiggle? They're trying to stabilize it on the yaw axis. But there's still something not quite right here. Do you see that they're not pointing straight up? Okay. When we're in VTOL mode, we want them pointing straight up as their sort of default baseline, and then we want them to sort of wiggle to affect the yaw axis. How do we do that? That's the next 2 lines in the setup. So I'm going to add 2 new mixer rules. And they are going to be, again, for servos 5 and 6. And what we're going to do is set that to max. And max just means we're going to add a fixed value. I don't know why they say max, since it's not the maximum, it's a fixed value. And you can see here that we've got multiple lines here for servos 5 and 6. And the way that works in the mixer tab is they just add together. So we're just going to add a fixed value. We're going to have the stabilized yaw, but then it's going to have a fixed value added to it to make it point straight up and down. So I'm going to come here and I'm going to manipulate the weight value to adjust the servo position here. And I'm just going to do it by trial and error. I do want to point out that if you put 0 in as the weight, which basically means the line isn't doing anything, it deletes the line. And that's kind of weird to me. I don't know why it would do that. But don't put 0 in as the weight or it'll delete the line. If you wanted to like 0 out the line, you would just put 1 in as the weight and it would just be the tiniest little bit of value. So with a weight of 100%, it seems to be in the middle position. That's also kind of weird. Let's just try changing this to 50 and we'll just watch the servos and see what they do. And you can see it has basically pushed both of the servos fully to their endpoints. So that's obviously not what we want. It's pushed servo 5 down and servo 6 up. Let's work with servo 5. If we take that to minus 100, it'll push it all the way the other direction, which is almost what we want, but not quite. Let's take it servo 5 to minus 50 and see what that does. And what we're looking for is that the servo control arm is exactly 90 degrees to the body of the servo. And you can see there's a little mark right here on the servo itself, and there are these 2 marks here on the servo control arm, and we're just going to try to get those to line up, and that'll tell us we're exactly at 90 degrees. So it looks to me like the servo needs to come back just a little bit more. You see, it's not quite vertical. So what I'm going to do, let's see, I went to minus 50, Minus 100 pulls it all the way back. So we need to go a little further back. So we'll go minus 55. For the right-hand servo, we're going to go to positive 100 to drive it all the way back. So here we're going to be working with positive numbers. Let's see what happens if we just put in positive 60. And I'm not going to waste your time showing you this. Basically, we're just going to keep doing the same thing. We're going to keep tweaking that value and sort of walk the right-hand servo in until it is also perfectly 90 degrees as close as possible. Now we come to an optional step in the setup. We have the ability to add aileron and elevator mixing into the multi-rotor mode. And we're going to go ahead and do that, but it's optional. You see, the aircraft can fly itself as a multi-rotor. It can pitch forward, roll left, roll right, just like a multi-rotor. It doesn't need control surfaces in order to control itself. But since you have control surfaces, they can be used to add just a little bit of authority, at least when the aircraft is in forward flight. So that's what these lines are for. Aileron and elevator, reduced weight optional. You can go ahead and add those, and I'm going to. Although I'm not sure if I did the first time I recorded this, so if later in the video these lines aren't there, that's why. So I'll come down to my mixer and I will add a new mixer roll. Servos 2 and 3 are my roll servos. So I'll add one for servo 2, and that's going to be stabilized roll. And servo 3 is going to be stabilized roll. And we'll just give that a weight of 50%. We've reduced the weight because ultimately, like, this isn't an airplane. It's a VTOL multi-rotor. And so it's not going to fly like an airplane. So we don't want it to like screw things up too much. You could experiment with a higher weight and see if you think it flies better, but we'll leave that how it is. And then servo number 1 is my elevator, and that is going to be stabilized pitch. And once again, we're on 50% weight just to give it a little less authority. The last two lines here have to do with making the transition from VTOL to forward flight and back. And the idea is that if we're in VTOL mode and we just switch to forward flight, we won't have any forward velocity. We won't have any air moving over the wings. And so we basically will just instantly be stalling the plane. And in fact, I did this by accident during a test flight. And what happens is the tail just goes, and now you're hanging on the props. And then if you have a lot of power, you can just fly straight up, but that's probably not what you meant to do. So what we want to do is temporarily tilt the motors forward, start to gain some forward velocity, get some airflow over the wings, and then switch to being an airplane and fly like an airplane. And that's called mixer transition, the transition between the two mixer modes. What we're going to do is go to the mixer tab, and we'll go down and add new mixer roll again for servos 5 and 6. That's the tilt servos. 5 and 6. And we're going to change that to mixer transition. And we're going to add a small weight into the servos to cause them to tilt forward at about a 45-degree angle. Now, there's a problem here, which is that we can't test this without enabling mixer transition mode, which we haven't set up yet. So in order to find the correct weights, I'm going to change this from mixer transition to max just for setup purposes, and then back to mixer transition when I've determined the correct values. And I think the thing I'm going to do is I'm just going to subtract out these two max values because they were at pretty close to 45 degrees. So for servo 5, we're adding minus 60, a consistent value of minus 60. So when we go into servo transition, we will add 60 and minus 60 for the other one, and we'll save and reboot. And now they are at about a 45-degree angle, which is about right. Keep in mind that it is using the servos to affect yaw. So if you tilt too far forward in transition mode, instead of affecting yaw, the servos will be, well, they'll kind of be affecting roll. And so you don't want to go past about 45, maybe 50 degrees, or the mixer will get all screwed up and the plane won't fly right. So yeah, that angle looks fine. We're going to then change this back from max to mixer transition and mixer transition. And now that adjustment will only apply when we're in mixer transition. The next thing I want to do is go to the Modes tab and set up the mixer transition mode. And we're basically going to have two aux modes we're going to set up here that'll be used to switch between aircraft and VTOL mode. Those aux modes are going to be down here at the very bottom, and it's going to be mixer profile 2 and mixer transition. I'm going to use this switch, this 3-position switch, to switch modes. And I'm going to need to add a mixer profile 2 and a mixer transition. And that is going to be, for me, on channel 9, maybe whatever channel works for you. And what I want is, okay, when I first power up, the switch is going to be in the up position, and we are going to be in VTOL mode. We're going to take off like a multi-rotor. If we didn't want to do that, we could just move that switch, but the default is going to be that we're going to be in VTOL mode when we first power up. So Mixer Profile 2 mode, when that is active, we will be in VTOL mode. So there, Mixer Profile 2. And then Mixer Transition, when that is active, the motors are going to go into that. The mixer will apply that additional tilt. And that's, well, we could make other changes in Mixer Transition, but that's the only change we're going to make at this time. That's going to be the middle position. And then the down position will be Mixer Profile 1. We will be an aircraft. So I'm going to save that. And when I do that, let's test that it works. Here, we are a VTOL. Here, we are still a VTOL, but we've got the motors with additional tilt to gain some forward speed. And here, we are going to go be an airplane. Except, do you see it hasn't switched to Mixer Profile 1? It stayed in Mixer Profile 2, and these motors didn't go full forward. They went back to VTOL mode. Again, there is either a bug or a feature that I don't understand, where until you've finished calibrating the accelerometer and done the rest of the flight controller setup, it won't switch mixer modes. So it's not going to work for you right now, but I can assure you that it will work by the end of the video, and you just have to take my word for it. Mixer Transition, VTOL, aircraft, it's just not going into Mixer Mode 1. We could manually change it. Here in Mixer Profile 1, we have a problem, which is that these servos, yeah, we don't have anything for the tilt servos. For the tilt servos, we just put stabilized yaw as like a placeholder for those servos. That's not what we want. We want a max value, and we want a max value that is going to make the servos point straight forward, because when it's an airplane, they should point straight forward. And that's going to be, I believe it's minus 100 and 100. No, because that's already what it is. No, it was, yeah. I believe it's minus 100 and 100. Save and reboot. Nope, that made them point straight up. Well, it's the other way then. Come back down here to servos 5 and 6. Let's try 100 and minus 100. There we go. Now they're pointing straight forward. That's what we want. Mixer Profile 1, we have an airplane. And Mixer Profile 2, we have a VTOL aircraft. And when I flip the transition switch, they go to 45 degrees forward. One other thing to check is the yaw axis moving the correct direction. So when I yaw to the left, it's a little confusing because the plane is pointing down frame. When I yaw to the left, the nose should go this way. That means that this motor should go back and this motor should go forward. Yaw to the left, yes. Do you see that they are moving the correct direction when I yaw? If that were not happening, if they were moving the wrong direction, I would go to the mixer tab, and here for stabilized yaw, I would change the weights. I would invert the sign of the weight. So instead of minus 100, it would be plus 100. Frankly, they're still not going very far. Why aren't they going very far? They could go further. They're not even barely going all the way. Weird. They'll put 150% weight. I don't know. The next thing I want to do is set up differential thrust in the airplane mixer. The reason we're doing this is that this airplane doesn't have a rudder, so we have no yaw authority when we're in airplane mode. But we do have two motors on the wings, and if we make one of those motors spin faster and one spin slower, then it can cause the airplane to yaw, and that's yaw authority is very nice to have. The way we set that up is we go to Mixer Profile 1. We're going to go here to the motor mixer, and we're going to tell the airplane that this motor can affect the yaw axis by setting this to a non-zero value. The guideline from the iNav devs is that if your airplane doesn't have a rudder, you set it to 1 and minus 1. If your airplane does have a rudder and you just want a little additional authority from the motors, you set it to 0.3. So I'm going to set that to 1 on the left motor and minus 1 on the right motor. And again, I will double check that later when I'm testing the motors to make sure that the correct motor spins faster and the correct motor spins slower so that it's yawing the direction that I expect it to yaw. Next, there are some command line options that we're going to need to paste in from the wiki. They are right here, load parameter preset templates. And we're not just going to paste these in blindly because not all of them will apply to us. So what I'm going to do is I'm just going to copy right here, and I'm going to copy and I'm going to put that in a notepad file, and I'm going to just go through it and look at which ones we need to adjust. So this stuff looks fine. We are not going to set the motor protocol to D-shot because I happen to know that the wing ESC support D-shot, but the tail ESC does not. I tested that off camera, and the tail ESC doesn't spin when we are using D-shot. So we can't do that. We'll just delete that line. And that seems fine. We may tweak that later, I don't know. The servo PWM rate, I don't know if these servos support higher refresh rates. So if you want better performance from your servos, set this. But if you don't know for a fact, there's a risk that you'll damage the servos unless you know for a fact that these HEEWING servos support higher refresh rates. So I'm going to delete that. And I'm going to leave this line because we are using servos for stabilization in multicopter mode. That's fine. Profile 1 is airplane. Profile 2 is multirotor. That is correct. This stuff we have already done in the GUI. Model preview, yeah, leave that. Mixer PID profile linking on. We've already turned that on, but fine. Mixer profile 2. I actually think this platform type equals tricopter and model preview type equals 1 may not work in 7.2. I don't know. That didn't seem to have a tricopter, so we'll just leave that. And then we've got some filtering and PID stuff for the airplane and filtering and PID stuff for the multirotor, which we will just leave as recommended. If models using control surface, yeah, that's fine. That's all fine. I don't understand all of that, but it's recommended by the devs, so we'll just run with it. All right, that's what we're going to do. We will right-click, copy that, and we will go to iNav. We'll go to the CLI tab, and we will paste all that stuff in. Type the word save, and voila. We are nearly done configuring this flight controller. There's one more thing we need to do before we go back to the bench and button up the airplane, and that is calibrate the ESCs. So if we were using D-shot to talk to the ESCs, D-shot is a digital signal, and basically it says digitally, I want 55% motor output, 60%. It's just a number that it transmits digitally to the ESC, and that number is what it is. But with an analog signal, basically like, it's almost as if I said, that's 0% throttle. That's 100% throttle. And then I went, and that's how I told you how fast I want the motor to spin. It's kind of a silly analogy, but it's very accurate. And can you see that if I hadn't told you is 0% throttle, and I just go, well, what percent throttle is that? What if is 0% throttle? And I'm going, what percent is that? You don't know. That's what the calibration does. Calibration tells the ESC what the endpoints of the throttle are so that when that analog signal comes in, the ESC can know what percent, what output the flight controller wants from the motors. Here's how we calibrate the ESCs. The first thing we're going to do is we're going to have the ESCs powered down, and I'm going to leave my props on because I have a smoke stopper and I'm lazy. But if you don't have a smoke stopper, you should turn your props, you should take your props off because the motors could spin. They shouldn't, but they could. We're going to go to the Outputs tab, and we are going to, I understand the risk, propellers are removed. My propellers are not removed, but again, I've got the smoke stopper to protect me. The motors cannot spin up. The smoke stopper will trip. Do you know what a smoke stopper is? I'll give you a video about a smoke stopper in the video description if you're curious. You should have one. Then what I'm going to do is I'm going to raise the master slider all the way to 100%. And when I power up the ESCs, I'll hear a funny little song that I don't usually hear. That means we're in calibration mode. The next thing I'm going to do is, in one smooth motion, lower the master slider all the way to 0. And I'll hear that funny little sound. And now my ESCs are calibrated. We basically told the flight controller what the endpoints for the ESCs are, the top and the bottom endpoint. If ever you replace an ESC, or if ever you replace the flight controller, you need to run that calibration again. The next thing we need to do is adjust the endpoints of the servo's travel to make sure the servo is not going to basically just bang into anything. And hi, it's Joshua from the future. Originally, I said we don't need to do this because if you look right here at this servo bracket, if I move the yaw axis all the way over, you can see that it doesn't hit the servo mount, and I thought I was good to go. But, haha, look at the propeller. Do you see? The propeller is striking. And in fact, I'm not going to move the plane over to show you, but it actually cut into the wing just a little bit on the other side and chipped away at the motor mount. So we need to adjust the endpoints. And what we're going to do is we're going to do just what I did. We're going to power it up. We're going to have it in VTOL mode, and I'm going to just yaw all the way to one side, which will cause the servo to tilt all the way to one side. And when I do that, I can see that the propeller is touching. And then I'm going to adjust the endpoint of the channel. And the first question is, which channel do I need to adjust? And if you look, when I yaw to the side, do you see that channel 6 goes all the way to maximum, whereas channel 5, which is the other tilt servo, doesn't go to maximum, right? So clearly channel 6 is the one we're pushing all the way to one end of its travel. And we are pushing it, you can see it goes to the top here, all the way to the maximum of its travel. So we're going to adjust the max of channel 6 or servo 6. And here we go. We're just going to take that in a little bit from 2000, and we'll take it in. Let's just take it to 1990. Take it in 10 points and save. Sometimes, yeah, there's a servo freaking out. Sometimes when you just hit save on this tab, a servo freaks out and I don't know why. So I'm going to hit save and reboot instead, and that prevents it. I don't know why that happens. I wish we had a manual servo control slider like we have a manual motor control slider. It would make things like this easier to do. Anyway, let's check now. We'll just put this propeller right here. We'll yaw all the way to the right, and it's still making a little bit of contact. We're going to bump that in just a little more. We'll just take that to 1980. Save and reboot. There we go. Clear, completely clear. Now that servo cannot interfere. And now we're going to do the same thing for the other wing. You're going to think this is dumb, but every time I have done this, I have approximately doubled the number of satellites I lock on my GPS, and I do it on all my GPS builds now. You wrap the wire. Well, in this case, it's aluminum foil. Normally, I would use aluminum duct tape, whatever that is, but I can't find my roll of tape now. So we're going to go with aluminum foil. And we've also, I don't know if you can see, twisted the wires. That helps. And then this is a little bit less robust than duct tape. So I'm also going to cover it in this wire harness tape just to keep it from falling apart and to keep it from short-circuiting on anything. 1 second. I used to think this was dumb because the foil isn't grounded to anything. So therefore, how much protection could it really give? But my test results cannot be, they speak for themselves. Every time I do this, the performance of the GPS gets a lot better. So I just do it. There we go. The wire's a little stiff, but it'll be all right. We're just gonna feed that up through here. Annoyingly, this GPS doesn't have a forward-facing arrow that I can see. But on an iFlight drone, it would be installed with the plug facing forward, so we're going to assume that's correct. And again, this is an issue that we will completely sidestep if we don't use the compass. See, more motivation to not use the compass. And then there is a cover for this, and it's supposed to be glued down with, I guess, hot glue or CA. I'm not sure. I'm not even going to do that yet. I'm not even going to do that. Who knows what kind of trouble I'm going to get into. Moving on. It looks like the top is flush right here, so we can stick this right near the front and have this USB port flush with the top, so when we plug in USB, it doesn't push against the sidewall of the fuselage. Let's just test that. Top goes on, flat, no problem. And then the receiver antennas, boy oh boy. That's a tough one. I don't even know. Like, we should have the receiver antennas at a 90-degree angle to each other for best diversity, but that would involve having one of them vertical and sticking out the bottom. Like, there's no way to mount this vertically without having it stick out the bottom of the airplane, which means that every time we land, it's going to get dragged, which I kind of don't like. Could we put one of them flat on the bottom like that, and one of them out the top, kind of like this, And maybe that would be some kind of like useful diversity. We're not going to be doing super long range stuff. We're not right off the bat anyway. So I'll tell you what I'm going to do. I'm just going to kind of jam them in there and figure it out later. I kind of don't know where the battery is going to go in terms of the CG of the plane. It's the main way you adjust the center of gravity of the plane is by moving the battery forward and backward. So we're just gonna, oh, can I go underneath? That'd be nice. We're just going to put it in the middle and cross our fingers. Finally, I feel confident about what screws I'm going to use. I hope this USB thing isn't in the way of the battery. I guess we'll find out. And then there's one more thing I want to do, which is add some grip sticky battery pad to this so that the battery cannot slide forward and back. After all, if the CG is important, then it needs to not change. And I don't have much confidence that this battery strap's going to keep it from moving. Alrighty, we should stick the receiver down somewhere, even though we're not done yet permanently placing everything. Oh no, I have to put the top of the flight controller on. What a pain in the ass. I should have really done that before I stuck all this down, but oh well. Yeah, we've got these 4 little washers here, and where's the plate? Where's the plate? Oh, and this plate here. Before we go fly the aircraft, we need to calibrate the accelerometer. And I know I did this because I've flown the aircraft. Hi, this is Joshua from the future again. But somehow I apparently didn't record it. So you need to go do this. You need to hit the calibrate accelerometer button, and then you're going to hold the aircraft in one of these orientations. I suggest you start with upside down, because for some reason in the past, when I've started with right side up and then gone to upside down, it resets the right side up one and I have to do it again anyway. So hold the aircraft upside down, flat and level, and hit calibrate accelerometer, and then this will turn blue. And then hold it in each of the other orientations, and each time hit the calibrate accelerometer button, and when you're done, you will have all 6 of these in blue, and your accelerometer will be calibrated, and you'll be ready to go fly. All right, before we put props on and actually go try to fly this for the first time, we are going to do a control check. Just one last check. It's going to be a little tricky to do this on the bench because I don't have enough camera to show you everything, but the airplane is powered up. Okay, so we've already done the basic, controls check in airplane, mode. That all is fine. What next? Let's check the transition. So switch up in default position is VTOL, transition, airplane. Good. All working as it should be. I don't know why. Something about calibrating the accelerometer did it, I guess. I don't know why it wasn't working before. Let's arm. Yeah, let's put it in airplane mode and arm. Oh, it doesn't have GPS. It won't arm. So instead, if you hold right on the yaw stick, you can override that and arm without GPS. So there we go. We are armed and we raise throttle. And the only thing really to check here, number 1, we'll make a note of the motor direction. So when we put props on, we can know it. They are props in. And we'll check our yaw mixing. So if I yaw left, this motor should slow down and this motor should speed up. Oh, whoops. Yes. Correct. That's working as should be. Okay. Now we will switch to multi-rotor mode. There we go. And then we'll make a note of the motor direction and we'll double check. So yaw left should be this one back and that one the front. So they should go this way. Yep, yaw left, yaw right, good. And roll left. This should slow down. Yep. Yep. Pitch back. The front motor should both speed up. The back motor should slow down. And vice versa. Checks out. All our controls check out. It's time to go fly it. And obviously, I don't have enough room on my property to fly this thing around, especially at my skill level. So we're literally going to take off. We're going to transition to forward flight. We're going to establish forward flight, and then we're going to transition back to VTOL, and I'm going to fly it back around. But at least we'll have proven that the damn thing flies. Moment of truth. Here we go. Yes! I don't know why I freaked out there. I don't know what that was about. Come home, baby. Come home. We do it again? Let's bring it home. We did establish forward flight. There we go. All right, ready? Here we go. Maybe we'll get a little forward speed first. Forward speed. Yes. Oh, that was interesting. Okay, still some kinks to work out, but overall, it is successfully doing its mission. And now we will land at VTOL, which, given how easy it is to launch a little plane like this, is actually the real appeal of VTOL. Oh boy, turn this way. Hold on, slow down. Okay, here we go. I got it. Thank you. Thank you very much. Yeah, that was a good job. This was such a freaking adventure for me. I have built planes before, but it's been a long time. And I never built an iNav plane. I never built a plane with a flight controller in it at all. I'm thrilled to have done this, and I'm thrilled to continue. For example, put a camera in the plane and a video transmitter, yeah, and then test out all the stuff iNav can do with planes. How does position hold work with a plane? How does loiter work? What about all these flight modes that really only make sense on planes and not multi-rotors? I'm going to be doing all that stuff, and they're going to be going in a playlist. I have an iNav 7.x playlist. It's already got a couple videos in it with multi-rotors, and if you want to check those out, like, figuring out how to calibrate the compass. Oh yeah, we're not using the compass on this plane because it's such a pain in the ass. Well, I got content about that. Check that playlist out and keep coming back to the playlist, because as I continue to do stuff with this plane, auto launch, where the plane will like launch itself into the air. Oh, auto landing. I don't know what I'm going to get into, but it's all going to go in the playlist. I'll put a card on screen. Check it out. And I'll put a link in the video description if for some reason you can't see the card, and I will see you there.